right, so here is the first video of notes. This is going to cover 5.1 for Unit 5. This is the first video of the Unit 5 notes. This is basically going to cover the intro to rational kind of ran out of room here, rational expression, rational exponents, and then also kind of radicals, all right? Which again, radicals essentially just means it's essentially it's like square root, but we're not just going to be dealing with the square root. As you can see down here, we're dealing with going now with fourth roots, fifth roots, sixth roots, all that kind of stuff. Okay, so essentially that's what Unit 5 is going to be dealing with. We're essentially just dealing with rational, numbers, rational, and how to like simplify, how to deal with them, operations on how to use them, so on and so forth. And rational exponents, we write it right here. So like say it's like a to some, or actually no, let me erase that real quick. Oh, let me erase that. I'll go to here and let me get black here. So say you have some number x, all right? X is just some number. And when we mean rational exponents, we basically mean it's some exponent that's a fraction. So it's going to be it's going to be x to a over n power. All right, your power is going to be an exponent. And when we write that out, when we kind of see that, we can see that we can go from a fractional exponent here to a rational. All right. And what it's going to do is this bottom number, the denominator of our exponent, is going to be whatever root it is. So it's going to be to the nth root, the denominator, and then x is again the number inside, and then whatever number it is inside, we raise it to the 8th power. We can also rewrite this as, again, the nth root of x, and then we can raise that entire thing to a as well. And again, I'll kind of flip-flop between the two of these kind of here right there. I mean, a classic example, kind of the most common example is x to the 1/2 power, all right? And remember that anytime you take a number to a fractional exponent, the bottom number is the number of the root. And if you have a number, and if the number of your root is 2, if you have the second root, that's basically the same as square root. So taking the x to the 1/2 power is literally the same as taking the square root of x. And try it in your calculators. If you do the 4th to the 1/2 power, that's going to be the same as 2, which is also the same as the square root of 4. If you take 9 to the 1/2 power, you're going to get 3, which is also the same as the square root of 9. And so on and so forth. All right, that's basically kind of the most common examples that we do with rational exponents there. So let's kind of convert from radical to exponential form. So again, we want to be able to, again, write a radical form like this and this in exponential form, and also vice versa. So we go fourth root of h to the 6th power. We're going to start off with just h, and again, it's going to be h to some fractional power. And remember, the number of the root is on the bottom. That's our denominator. So it's going to be h to the 4th power, and then on the top, it's going to be h to the 6th power, all right? So again, remember, it's always the bottom number here. The denominator is always the number of the root there. In example number 2 right here, you got the square root of k to the 7th. Now this one, square roots are a little bit weird because you don't usually see us write the 2 out in front there. But, because square roots are so common, we're not going to write that little 2. We're not going to write that little 2 right there. All right. So if you ever see a radical symbol, basically the little square root sign with no, let me get the pen there, with no number of root there, then you always assume that it is the square root of 2 and the root number is 2. So again, it's going to be k, some fraction. Again, the bottom number is 2, number of the root is 2, so bottom number is 2, and then k to the 7th, that number goes on top, so it's k to the 7th over 2 right there. All right. Example number 3, we're going to go the opposite way here, all right? We're going to go from x to the 5 over 2nd power. We're going to go from exponential form to radical form. So first thing we're going to do, just go ahead and draw the radical with the x there. Remember, bottom number is the number of our root out here, all right? So, but since it's the number 2, that tells us it's going to be a square root, so we really don't need to write the number 2 out there, all right? And then 5 power, we're just going to bring that underneath here. So it's going to be x, the square root of x to the 5th power. And if we go over here, again, going from exponential form to radical form, we're going to do a root there. Bottom number of our fraction is the number of our root, so that goes on the outside here, the 4th root of b to whatever power the top is. So it's going to be b to the 3rd power on top, all right? So again, that's just a little bit of, just a little bit of kind of just kind of intro demonstrations here. Let's look at a couple numbers here. So let's actually use a couple numbers here. So example number 5, it's going to be 49, 49 to the 3/2 power, all right? So essentially, what this basically is, again, if we basically did kind of what we did the last time, we're essentially going to move this into radical form. Again, bottom root sign with a 49. Bottom number is the root, so it's 2, so I don't have to write it. So it's literally the square root of 49. Now, what I was writing before, it was the square root of basically the square root of 49 cubed. And if you wanted to find what 49 cubed was and find the square root of that, you could most definitely do that. But for me personally, and that's also kind of why I did this second term right here, we could take out this 3rd power all the way outside to where we are only finding, where we're finding the square root of 49 and then taking that entire thing to the 3rd power. And again, if you know, the square root of 49 is just 7 cubed, and 7 cubed is 343, okay? Now, 25 to the negative 3/2 power, we have basically negative 25 to the negative 3/2 power. Again, we want to turn this into a radical, so it's going to be 25 underneath the radical sign. Bottom number, again, that's the number that goes outside here, but it's a 2, so I don't have to write it. So it's basically the square root of 2, square root of 25. And then I'm going to write my top one on the outside. Now, this is technically a negative 3/2, so I have to write it's square root of 3, square root of 25 to the negative 3. And this kind of goes in line with some of our some of our exponent rules here. Anytime that we have an exponent, we're essentially going to treat this square root of 25 to the negative 3 over 1 as a fraction over 1. And we're going to take this entire thing right here and just literally switch it to the bottom. We're going to be left with 1 on top, and then the square root of 25 to the 3rd power on the top, on the bottom. And again, if we work it out, we get 1 over, square root of 25 is 5, square root of 25 is 5, 5 to the 3rd power is 1 over 125. Which if we work out in some decimal, it's like 0.008 or something like that, so. Okay, so that is basically kind of the really basic introduction of rational exponents. Now I'm going to kind of, actually I'm going to switch out of this, PowerPoint slide. I'm going to go into another one here. I'm going to go chapter 10 notes right here. Actually, no, not that one. Let's go documents. Sorry, you're looking at my stuff here. So radical expressions, and then let's go property of exponents. So when we're in this chapter, so this is kind of a start to 5.2 right here. This is kind of a start to 5.2, kind of dealing with properties of exponents. Now, this is stuff that you actually learned back in Algebra 1. This is, if you kind of try to look back to Algebra 1, this is a lot of stuff that you learned, but this is also stuff that we've been using in class already. So, for example, for this first one, multiplication between bases, you add the exponents. If you take x times x, x to the second times x to the second, remember we're adding these top exponents here, and if we multiply those out, we would just get x to the 4th power. Remember, if we take a power to a power, so again, say if we had, let's say, 5 to the 2nd power, and we raise that to the 3rd power, what we'd ended up doing is essentially we would multiply these exponents here, multiply this 2 and this 3 here to get 5 to the 6th power, and then we simplify that as further. Another one that we've used a lot is this one right here. Essentially, it's just kind of the distribution right there. So I'm just going to do this. So you have a third power here. You have a 5 to the x to the second times y to the first times y to the first. And if we raise this all to 1 power, we're essentially going to be distributing this power as a power to all of the terms inside there. So if we do that, we're going to get 5 to the 3rd power, and then we do x, and again, power to a power, we're going to multiply these numbers, so it's x to the 2nd times 3, which is just going to be x to the 6th, and then this is y to the 1st power, so y to the 1 times 3 just gets you y to the 3rd power, all right? So that's basically that right there. Again, raise more than one variable in the parentheses, distribute it to every single term. I know there's a lot of people that kind of remember kind of the last chapter, we would have 2x squared, and a lot of people would write it as 2x squared. That's not what it is. Remember, you have to distribute the 2 to both the x and the 2 to get 4x squared. All right, have to distribute the square to every single term right there. All right. Negative exponent right here, we've worked with that already. If you got x again, so if it's x to the negative 2nd power, literally flip it as a fraction, go to the bottom, turns it as 1 over x to the 2nd power. A to the 0 power, again, anything to the 0 power with an exponent of 0 is just the number 1. So literally, if I take 155,000, 71 to the 0 power, that's going to be equal to 1. If I take 11 to the 0 power, that's going to be equal to 1. All right. All of those numbers to the 0 power are equal to 1 there. Okay, so 1 on top, so 1 on and 1 on bottom, you subtract top minus bottom. So basically, again, if it's basically x to the 6th divided by x to the 5th, we're essentially going to take this 6th power and subtract it from this 5th power here. So it's going to be x to the 6 minus 5th power, which gets us just x to the 1st power, or just x. All right. Now, now something from that is if you have a number on top, the number that's bigger on bottom from the top number, you would still subtract this top number from the bottom number. So it's going to be x to the 5 minus 6, which gets you x to the negative 1st power. But remember what our negative exponents tell us, that we need to move that to the bottom of the fraction there, all right? Kind of a rule of thumb, and whenever you're subtracting numbers from top and bottom, if it's bigger on top, so if it's big on top, it's going to remain on top. If it's bigger on bottom, I'm going to go B-O-B, Bob. If it's bigger on bottom, then it's going to move. It's going to move to the bottom. All right. And then lastly, here you have exponents outside parentheses, distribute everything inside. If it's x over y to the 3rd power, distribute it to both the top and the bottom. And even so, say if we had 2xy over 3 y squared or whatever, we would still distribute this 3 to the numbers as well. We distribute them all out. You get yourself 2 to the 3rd power. I'm not gonna simplify it, and then x3, the y, y3, then 3 to the 3rd, and then y to the 3 times 2 again, which is the y to the 6th. Okay. So again, that's property of exponents. That's actually not technically in our note packets. This is kind of that little extra sheet that I gave you guys. I will make sure that this is also this kind of presentation is also a PDF on Classroom for you guys to work out as well. And that's basically where I'm going to leave it for today. I will keep making these videos. Hopefully I'll be able to get some more out tomorrow. This is the only one I'm going to make today. So again, that was basically, I'll kind of move it back. I'll kind of move it forward in the slide here. So you kind of look up over here. So that was essentially in that video, 5.1 and 5.2 in our notes there. So 5.1 and 5.2 notes right there. All right. And thank you for watching. Have yourself a good day.